It's 29. I worked it out on a piece of paper. I'm sure that passed around too. The fractions you guys are not liking. Okay. Okay, so plug something in and let me show you. Even though I want you to do it by hand, but do this for me. Take out your calculator for just a second. Everybody take out your calculator. Now remember, all fractions in your calculator must be in parentheses, okay, especially if you're doing something else. But let's say I was plugging in 3/5 and I wanted to square it. So I want you to all take out or all in your calculator do parentheses 3 divided by 5, close the parenthesis and square it. Do that right now on your calculator and tell me what you get. 0.36. And you go, but wait, I need it in a fraction, right? You see that button that says math right under the green button? Hit math, enter, and then tell me what you get. And suddenly you're back in a fraction form. Does that help you? If I squared 3/5, I would get 3 squared is 9, 5 squared is 25. Your calculator will put it back in a fraction for you is what I'm trying to get at. Math, enter. Here's another little nifty trick I'll teach you with your calculator real quick. I don't think I taught y'all this till calculus. Let's say this is the x value that I wanted to plug into my equation, right? If you do, parentheses 3 divided by 5, close parentheses, there's a little button on there that says STO. It's right above the on button, I think. Do you see it? That means store as a value. Hit that STO button, you'll get this arrow that comes up, and then hit the X button. The X button is right beside the green button. Does everybody see what I'm talking about? Let me put it on. Now I want you to show me how you're plugging in. But if you want to use this to help you evaluate, it is a lot easier. What's terrible? This is terrible? All right, so if I do 3 divided by 5, I hit the STO button that's right down here. STO. And then the X button here. And hit enter. Now, anytime I call up X, it's going to read it as that value. So if I wanted to do X squared, whatever it is, let's say I had a whole equation. Let's say it was 2x squared plus 5x minus 7. It plugged that in for me. And then I could go back to math, enter, and it would put it as a fraction. It's a pretty handy little trick, right? Yeah, I was going to say yes because it is. All right, let's move on then to homework. Questions about your homework. Which one? 31? Is that what somebody said? 31? Before you graph it, tell me what you know. Were we talking about that in this class, or was that third block? I talked about you, Dylan, as the kitten killer. Now, there's a poster back there that says every time you do this, a kitten dies. Because you can't cancel those terms out because you're not multiplying. But Dylan does that all the time, and he does it so much that a lot of times they'll run a counter on the board that says, how many kittens has Dylan killed today? And every time he makes that mistake, they put a tick mark on the board. Anyway. All right, tell me what you know about it without even graphing it. What? A, B, and C. What else do you know? Okay, so 5 is the what? Y-intercept. What else do you know? Yeah. Okay, up or down? Up. Why? It's positive. The first number is positive. Is it skinny or wide? Why? You got it. Good job. That's actually bigger than 1 because it's an improper fraction. So it's skinnier than normal. So that's what I should get whenever I graph it. All right, let's find the vertex first. All right, let's list A, B, and C. What's A? 8 over 5. What's B? And C? So to find the vertex, I do what? Opposite of B over 2A. So if B is -4, then the opposite of that is +4 over 2 times A. Now you got to think back to some of those skills you learned with fractions. Is your whole group missing? Oh, I'm sorry. Man. Did I miss another? Like, who else is missing from yours? Okay. Don't remind me whenever I finish this. Check my 10 minutes. All right. So when you're working with fractions, you want to simplify the top and the bottom first if you can. So I can simplify the bottom here, right? When you multiply fractions, you multiply top times top and bottom times bottom. Yes? Everybody okay there? So this is really 4 over, and this fraction becomes 16 over 5. I never want to divide by a fraction, so instead of dividing by a fraction, what do I do? You will probably hear me say this so many times by the end of the semester that you'll be tired of hearing it. Never divide by a fraction, always multiply by a reciprocal. Have y'all heard that before? So instead of trying to divide this out, I take the top of the fraction and I multiply, and what I'm going to do is flip this over. So it's going to be 5 over 16. Everybody okay? So this becomes 20 over 16, which reduces to what? 5/4. This is just my x. I did all that work just to get my x. Are y'all okay? Yes, no, maybe so. You got 1.25, that's the same thing there. Okay? This is the hardest part of these with the fractions, is finding this vertex. Now, if this is the x, I still have to go back and plug it in to find y, right? Gross, but we're going to do it anyway. All right, so now I'm going to take this, and everywhere there was an x, here and here, I'm going to substitute 5/4. 8 over 5 minus 4 times 5/4 plus 5. Now, everybody always asks how much work do I need to show. You need to show at least as much work as what I show you in the examples up here to get credit. Okay? If you want to use your calculator at this point, I am okay with that, as long as you can show me where you plugged it in like this. So then if I took my calculator and I said, okay, well, that's going to be a lot of work, right? I'm going to do that little trick that I showed you a second ago. I'm going to store x as 5 over 4. And I am just going to type that equation in here. So that equation was Go back and look at it. 8/5. Remember, any fraction goes in parentheses. 8/5 x squared, right? Minus 4x plus 5. If I need it as a fraction, what do I push? Math, enter, enter. Math, enter, enter. 5/2. That was a lot easier than squaring this, multiplying, finding common denominators to add and subtract, right? Are y'all okay? So this vertex is 5/4, 5/2. Agree or disagree? Y'all got to talk to me a little bit. Tell me what's wrong. Are y'all lost completely? Are you bored, or what's, you okay? Okay then, I'm gonna assume y'all are good, and I'm just gonna keep trying. Yeah, yeah. That's the coordinates there of the vertex, yes. So 5/4, remember, that's like 1 1/4, right? So whenever I graph this, I'm gonna go over about 1 1/4, and you don't have to be exact in this, but you do need to be kind of neat as you do it. And then I go up 5/2, which is 2 1/2. So I'm going to go up 1, 2, and then another little half. So here's my vertex. Because this one is so what I'm probably going to do is for my easy point, I'm just going to pull this y-intercept and use that. So at 5, so I'll go up 1, 2, 3, 4, 5. There we go. And now the hardest part is reflecting that over, because I have to go 1 1/4. So 1 and then another quarter. Here, we'll put it in the middle. So there's my parabola. Have y'all been taught the graphing calculator things on the calculator before? Have you had a teacher that's worked with you any with the graphing calculator? Not a lot. So we can graph these on the calculator. Have y'all had a chance to get your calculators? Are we still missing some? I'm going to go ahead and show you anyway. That way it'll be in the recording. If you don't have it, you can go back and follow along and watch. But if I wanted to, remember, you got to show your work, right? Because that's how you get your credit and that's how you learn how to graph them. But if I wanted to check it, if you go to the button that says y equals up here, you can type that equation in. So I'm going to do 8/5 x squared minus 4x plus 5. Remember, your fractions have to be in parentheses for this to work. And what I'm going to do, instead of just hitting graph, if you hit the zoom button and go down to where it says zoom standard, number 6, that'll take you to a 10 by 10 window. Will somebody pick that up while that's over there close to it, please? Just say Miss McGee's room. Let's not all go at once. Y'all don't want to answer the phone? They're probably calling us for books. Parabola look like my parabola? Yes. And so it's just kind of a check for you there. We'll do a lot with the calculator. We'll also do a lot without the calculator. But calculators are good for helping us check what we're doing. Yes or no on that one? Or nothing. You say yes, or you say no? Okay, nah, okay. That wasn't really an option. That's okay, I'll take it, because at least you said something. All right, what else on your homework? Going once, which one? 27. I'll answer questions as long as you have them, but if you don't have them, I'm moving on. Yeah. It's always a possibility. They'll always be after I go over homework. Do what? Oh no, they're only like 1 to 2 questions. They're literally like 5 to 10 minute quizzes. Then their time could be they're always literally copied from your homework problem. They're just homework quizzes to make sure you did it. All right, 27. Y equals 2/3 x squared minus 3x plus 6. Tell me what you know before you graph it. It's y. How do you know it's y? It's less than 1. What else do you know? 6 is y-intercept. What else? It's going up because it's positive. Yes? First number's positive. Correct. All right, let's find the vertex. X equals. Oh, I forgot to list A, B, and C. I'm sorry. A is 2/3. B is -3. C is what? 6. All right, so up top I get what? 3/2 times 2/3. Again with the fractions, okay? So I'm going to work the bottom first. 3/4. And I don't want to divide by a fraction. What do I do instead? Flip. Multiply by the reciprocal. So I've got 3 times 3/4. What is 3 times 3/4? You look like you just ate a lemon vein. 9/4. Everybody okay? That gets plugged in for x to find the y. So y equals 2/3 times, there's my x again, 9/4 squared minus 3 times 9/4 plus 6. Yes? I'm going to use my calculator again. I'm going to store x as what? 9/4. Stores x, and I am just going to type this equation in. 2/3. Make sure you can type this in and get the right thing. Times x squared minus 3x plus 6. How do I get it to a fraction? Math, enter. So this is my vertex, 9/4, 21/8. Yes? One, 2, and 1/4, so I'm somewhere about right here. And 21/8 is 2.6, so a little past 2.5. 1, 2, there's 2.5. So about right here would be my vertex. Make sense? What if for this one I don't want to use the y-intercept? You could use 2 or 1. 2 is going to be really, really close. I might want to go over to 1, but 2, I mean, you could. There's nothing saying that you couldn't. With these, whenever I have all these fractions this way, if I can use the y-intercept, I definitely want to try that because this is a lot of plugging in and trying to get those fractions to work right with me. So I'm going to go up to 6. I'm going to use that intercept. And then reflect and connect. So 1, 2, and 1/4. 1, 2, and 1/4. There's my parabola. Thank you. Questions about that one? You okay? You see me after class individually and let me know. so we can figure out what we're going to do about that. Because as you can see, we're going to be dependent on calculators for a lot of things. They'll make your life a lot easier. Anyway, you ready? If you go in, it should be there in Canvas. It says notes. Yeah, the notes with the link to it. The very first. So today is 1/7. I try to head them by date. So go to today's date and then look under that. Y'all got it? What do y'all think about the mirror board? Do you like it or no? Or right? I think it's cool. I can set it, and sometimes I will. I can set it where you guys can write on it too while I'm writing on it. And we can collaborate. Sometimes that blows up in my face because people will just do what? It's a bunch of chaos a lot of times, yeah. But sometimes I'll unlock it for a minute and say, hey, you do this one real quick. And I have a whole class. I had the best of it. I have a whole classroom set of little styluses and stuff, and I bought them for everybody. And then, anyway, I digress. Sorry. Told y'all I get easily sidetracked. Y'all ready? We had a built-in brain break this morning. All right. So the final two forms. I know y'all are so excited. Vertex form and intercept form. We'll do vertex first. These are so much easier to graph in than standard form. Standard form is by far the hardest because there's so much work involved in which to do it. But vertex and intercept are a lot easier. All right, let's do vertex first. Remember, just like a line where we have standard form, slope, intercept form, and so on, we have three different forms of quadratics. And so we talked about standard yesterday, and standard looks like what? What's standard form of a quadratic? Ax squared plus bx plus c, right? All right, so vertex form is a times x minus h squared plus k. Looks a lot different, right? Some different variables in there, some of the same variables. So, oh my goodness, what are we going to do? Well, the A here does exactly the same thing that the A did in standard form. So that makes it easy, right? Say right, because that's right. Okay, what does A tell us? Negative or positive? So if A is positive, oh my goodness. Up or down? That's exactly right. So positive is up, negative is down. Wrong class, I think. Nope. Was that my sister? Okay. What else does it tell you? If it's skinny or wide. Same thing. So as the absolute value of A gets bigger, what does the graph do? Y'all are saying it, but you're whispering it, but I heard you. Graph is skinnier. And then vice versa. As A gets, smaller. What's the average? 1. Good job. This is called vertex form because the equation literally gives you the vertex. In fact, the vertex is HK. Whatever those numbers are in that equation, that is your vertex. Now look, most of our time was spent trying to calculate a vertex in standard form, right? We were like, oh my gosh. But in vertex form, it's there for me. I don't have to spend all that time calculating it. I just take it out of the equation. Now notice there's a minus sign in this original equation. So what that means is whatever this value is here, this is the H is going to be the opposite sign, and the K is going to keep the same sign. And we're going to do several examples to show you what I mean by that. We still feeling pretty good? Y'all told me that yesterday, but then we're not feeling pretty good. Yeah, I'm sorry. What do you think happens if H or K are missing? But like if they're not in the equation, they're zero. They're zero. If they're not there, they're missing. So if H, we'll write that down, or K are missing, then zero. And of course, if you don't see A there, then what is A? 1. Y'all good? All right. Tell me what you know about this one. You're very, very close. You said 1, -3. But what did I tell you about H? There you go. It's opposite sign. So the vertex here is -1, -3. That's the place where everybody always messes up. So make sure on that H that you flip that sign around so it's -1, -3. What else do you know? Positive, so it goes up. Positive is happy, right? So it's a smiley face, so it goes up. Skinny or wide or average? Wide, because it's less than 1. You all okay there? Tell me what you know. A is close, not just 1, but, and you might not have seen that because I added that in fast. A is -1, so is it up or down? Down. Skinny, wide, or average? Average, because it's 1. What else do you know? K is 0, which means the vertex is what? 2, 0. Everybody okay? See what we're doing? Ready to graph in vertex form? Bless you. All right, well, let's graph in vertex form. Y'all like the steps or not? The steps, yeah? Okay. How to By the way, a lot of you asked yesterday, I think I addressed it in class, when you see things like f of x or g of x, that's the same thing as y. It just tells us that what we're getting ready to graph or what we're getting ready to work with is a function, and it just gives it a name. We will get to a lot of that very, very soon. Yeah. Do the same thing as y. Y'all remember learning about functionality? If it passes the vertical line test, it's a function. Did y'all learn that? Has to have the same number of outputs as inputs. It can't have the same y repeated for 1x. If not, we'll go back over that and hit on it again. But this is just telling us that it passes those tests. That's all it does. It's just a name. All right. let's do 1/4 x plus 2 squared plus 5. Tell me what you know before we graph it. Going up. It's wide. Look at you go. Good job. The vertex is -2, +5. First thing we're going to do, same step as the other form. We're going to find and plot the vertex, just like we did before. But this time I don't have to do opposite b over 2a, plug back in, none of that. I just pull it straight from the formula. So we said -2, 5. So I can come right over to my graph. That's a terrible graph. Let me do better. I think I'm going to go by half. So I'm going to 2. This is 2, -2, 2, 4, 5. There we go. This, of course, being my, what's it called? Axis of symmetry. Everybody good? I need another point. Do you agree? I don't have this time, though. This 5 is not necessarily my y-intercept anymore. Notice I didn't tell you that was the y-intercept because it's not the y-intercept anymore. So this time I'm forced to do an easy point, okay? So when you do the easy point, I'm going to say find and plot easy point. Remember, I want to stay close to that vertex. So what I'm going to do is I'm going to look at the x value of my vertex, and I'm just going to go one to the left or right. It doesn't matter which way, just go one direction. So what do you think we could do for the x? What's a good easy point to choose? -3 or -1? Which one you want to do? 3? You should get the same thing no matter which one you pick because you're the same distance on either side, so it doesn't matter. All right, so if we do -3, now we're back to where we do have to plug in, but this one's a little bit easier of a plug-in than standard form is. Y equals, it was 1/4, and then x plus 2, right? So my x is -3. The hardest part about this is going to be remembering those order of operations. Parentheses, exponents, multiplication and division are equal, addition, subtraction are equal. So the first thing I need to do is do what? Add those two in parentheses. So what's -3 plus 2? Now what? Exponent. What's -1 squared? 1. So 1/4 times 1 plus 5 is what? Or 5 1/4, 5 1/4. Any of those ways you want to write it, 5.25. Any of those ways are just fine. But that's my easy point, right? I plugged in -3, and from it, I got 5 1/4. So I'm going to go to my graph, and I'm going to plot -3. So here's 2, there's 3. And I want to go 5 1/4. So this was already at 5, so it's just a little bit past 5. Does that make sense? That's the hardest step in this one, is that finding that easy point. and then just reflect it. Last step's the same too. Oh, I did this on the wrong side, y'all. Nobody told me. Ooh, that's supposed to go over there. Sorry. Now your notes are a mess and my notes are a mess. Y'all don't seem concerned about that. Did y'all put it on the right side? No. You did what I did, didn't you? Well, that stinks. Well, whatever. Reflect and connect. Y'all ready for the last one? What do you think? Easier? Harder? The same as standard? Easier? Okay. The reason I show you intercept form is because it is probably, it's the easiest most of the time for you to get to what we learn factoring. It's the factored form, essentially, is what it is. Before I show you intercept form, tell me what an, yeah. Oh, I'm sorry. Tell me what an intercept is. Goes through the axis. Okay, I could have an x-intercept or I could have a y-intercept. As I look at intercept form, I'm going to be talking about x-intercepts. So keep that in mind. You're used to talking about y-intercepts, but these are going to be x-intercepts. How many x-intercepts does a parabola have? I hear. Does it always have two? Let's think about this for just a minute. I could have, okay, if I put my parabola here, I have two x-intercepts. Do you agree? 1, 2. Can you think of a situation where I wouldn't have two x-intercepts? Ooh, that's awesome. If the vertex is on the x-axis, how many intercepts do I have? 1, technically. But I could have a zero situation. Can you think of how I could have a zero situation? What if it shifted up? What if it was up here, just like this? That one doesn't have any intercepts, does it? Or facing down below the x-axis, yes. Okay, so there's some different situations here. With intercept form, I'm going to be talking about parabolas that look like this red one, or like this, that have two intercepts. But I did want you to be aware that there are situations where you will have no intercepts or just one intercept. All right, let me show you what it looks like. Some new variables here. All right, guess what A does? Take a wild guess. What it always does. You're exactly right. It does what it always does. I'm not going to go through all that. It's still the same that it was before. Positive up, negative down, skinny, wide, all that good stuff. A still does the same thing. So that's nice, right? You don't have to remember all that in all the different forms. P and Q. Remember, we're talking about intercepts. The name of this form is intercept form. So it gives us the intercepts. So this one crosses the x-axis at these two values. But again, because I have these minus signs here, the signs are opposite of what you think they are. I know this is a lot from Friday, I'm sorry. So let me show you. Up or down? Skinny wide? Yeah. Yeah. Why wouldn't you? Yeah. Every night. Because it's the weekend, is that what somebody said? Yeah. You still have it on the weekend, I'm sorry. No? Huh? It'll be due by class Monday. What are the intercepts here? 1 and negative 2. Does that make sense? Okay. If I have the intercepts, and I want you to think about this before I show you how to actually graph it. That's telling me where it's crossing, right? That gives me 2 points on the parabola. How many points do I need to graph a parabola? 3, right? What point am I missing? The vertex. So that's going to be my work for intercept form, is the vertex form. Finding the vertex, okay? So let me run you through the steps and show you how to do it. Before I do, what do you know about the vertex in these 2 points right here? Or at least about the axis of symmetry? Do you agree that the vertex is going to be on the axis of symmetry? Do you agree that the axis of symmetry is going to be halfway between these 2 points? Got to be, right? Because they're symmetric. So if we can find the axis of symmetry, we could then find the vertex, right? That's what we're going to do, because the axis of symmetry is going to be halfway between. So if we can find that, we'll have the x value, and then we can plug in to find the y value. So let's do it. I do have y'all for enrichment today, so you'll have time to work on your homework. Okay. Golly, thank y'all. Y'all keep me straight. What am I doing? My brain is not even with it. Does anybody go to ATEC after this? Okay, you'll have to leave. You won't get to stay with us for enrichment, right? Don't you have to go? We might as well do that one we just did, right? First thing we're going to do is find and plot our intercepts. And we've already said that those intercepts were x equals 1 and x equals negative 2. What do I need to do now? Find the what? The vertex. How do you find exactly in the middle of two numbers? That's exactly right. Add them and divide by 2. I'm going to put a note on here. Find the axis of symmetry first. And to do that, I'm going to add the 2. So P plus Q and divide by 2. That gives you exactly in the middle of them, right? So my axis of symmetry, -2 plus 1 is what? -2 plus 1. -1. Divided by 2 would be -1/2. So all that's doing is telling me where that axis of symmetry is. And that's where we put it earlier when we were looking at this problem. How do I find where on this axis it is? If you know X, how do you find Y? You just plug it in. I get 1/2 minus 1 and 1/2 plus 2. What is it? Yep, thank you. So -3/2, and this should be +3/2. Get the number here, but how you graph it, if it's not graphed exactly, that is okay. Like this is going to be -9/248. A little bit past -1. You don't have to get into going, I don't know, I don't know where that is. It's just a little past -1. I know that was a little bit of a crash course in those two. We will definitely practice. I think my plan in all reality is probably going to be to practice all 3 forms on Monday and give us a day to work with them together. This weekend, you'll look at just these 2 forms where I'll say, it'll say graph this in Intercept Form, graph these are in Vertex Form. Monday, we'll work on them all being mixed up and you determining which form it is and how you need to graph it. Let me give you your homework. I do have to post these pages. I haven't posted them yet. I just remembered I hadn't. But you can go ahead and write down. You're going to do numbers 3 through 21 odd. These should go a lot quicker than the others. And let me post them. How was today compared to yesterday? Worse, the same, better?